Hi, everyone. So Mitch and I are looking at political language, specifically using congressional summaries. So in the past couple of years, we've seen a lot of polarization in Congress, and we're trying to see if we can identify key aspects of party language and how we may use that to get some party ID using natural language processing.
So the data that we use came directly from Congress's website. We created a web scraper that would extract the sponsor's name, their party, and then the title of the bill if there is one, and then the actual summary of the text that exists. We stored all that in a database that we created in SQL, and then using pandas, we're able to extract that data directly from that. So here we've got an example of our database. We've got our Congress year, sponsor name, party, bill name if it's available, and then the bill summary text itself. Looking at the bills proposed, we can see right away that from the 114th to 117th Congress, slightly more Democratic bills being proposed than Republicans, and barely any from the Libertarian and the Independent parties. So we ended up just ignoring those two from our data set. From there, we extracted the most common words within each corpus. But as we can see, without the removal of any stop words, there's kind of no meaning to be had within these graphs yet. So what we then changed up to do is to look at what are called shift rater plots. So the proportion of words that kind of tend to shift a document towards one party or the other. And so this, we're starting to get a little bit more meaning. We can see words like health and funds. Yellow here is Republican and purple is Democrat. And then we can do this again, looking at the Shannon entropy, and that kind of helps remove the stop words kind of artificially in a way. And so again, we can see health, education versus VA funds, things like that. And then we added our own stop words to kind of compensate for the fact that text bills are slightly differently worded than traditional English speech. And in doing that, we were able to get the 25 most common words in Democrat and Republican bills again. And this time we've got a bit more meaning behind the word frequencies here. And again, we can calculate a shift rater plot now with the stop words removed to again kind of emphasize how different words are kind of shifting a bill's prospective summary towards either Republican in yellow or Democrat in purple. So now onto the models.
We began using a bag of words approach. So we were using one called TF-IDF, which is term frequency inverse document frequency. So basically for this, it will do a vectorization and it will look at the frequency of one term in a document relative, and it will weight that with the inverse, which is the amount of times that term appears in the whole corpus or the whole data set. So we can look at, for this, we looked at both at unigrams and then also unigrams and bigrams. So one word and then one word and two word groupings, and then also one word, two word and three word groupings. So we're looking at that with these parameters called min df and max df. And so after you do that vectorization, you can kind of input that information into classifiers of your choice. So far we've looked at logistic regression, naive Bayes, and SVC. So we did some grid search that let us kind of try out some different parameters to make sure that we're getting our maximum amount of accuracy. So we kind of have slightly different parameters for each of our tests. So for logistic regression, we found that the best features would have no max features, to have a min 2 df and max 0.3 df, and to have between 1 and 3 words in each gram. And just using that standard stop word, and we were able to get an accuracy score of 69%. And we'll go a bit more in depth into some ROC curves later to look at some more parameters, but just as an initial test of how our model was doing. So then looking at naive Bayes, we did a similar pipeline and ended up getting slightly different parameters for what it found were the best ones. So it ended up using between 1 and 2 words here, and then slightly different max and min df. And this one was able to get, this one actually had a slightly lower test accuracy score. It got a score of 67.8%. And then looking at support vector classification, we did, same thing again, just kind of repeat the process, and we got our highest score yet. We got an accuracy score of 70%. So then we decided to look at ROC curves, which Mitch will kind of explain in a bit more detail.
Yeah, so as we saw in the very early on, there's a slight skew to our data set. So accuracy score might not be like the most optimal way of assessing our model evaluation. And so we decided to look at the ROC curves, and in plotting that, we actually got some really interesting results. So in this plot here, we can see orange. The orange plot in the middle is our logistic regression curve. Green is our naive Bayes, and then red is our SVC. And calculating the area under the ROC curve, we are able to get our logistic regression covered about 78.8%, naive Bayes about 75.1%, and then our SVC was able to get almost 83%. So that was actually really surprising given our initial accuracy scores. And we were quite pleased to see those results. For completeness, we also generated our classification report for each model. And we can see this common theme where the precision is okay and lines up pretty well with our accuracy that we were seeing before. But our recall, we were actually really struggling to identify Republican bills, but we're actually doing fairly well on identifying Democratic ones. And so moving forward, we'd really love to take a look at some more involved models. So right now we covered some pretty standard fundamental ones, but word embeddings and models like word2vec, in addition to transformers, should really allow us to expand our complexity of our models and hopefully be able to identify even better the differences that exist between bills proposed by Democrats versus Republicans. So we're really excited to look at how encoding words as vectors can change our results.